Good morning, students. Today we will see integration by successive reduction. Why reduction is required? Please see an example. For example, if you have e power x into sine x dx. So we have two functions here. When two functions product is there, we have seen we will integrate this by the method of by parts. So in the integration by parts there will be two functions u and v. We select the first function using the phrase isolate. So this is exponential function, this is trigonometric function. Therefore trigonometric function comes first, t comes first in isolate. Therefore, what is this? This is trigonometric function is first function. This is second function. Now I will apply integration by parts. What that rule says? First u into integral v dx. Next integral of d by dx of u. U means sin x into integral e power x dx. For entire product, once again we will have integration. So if I simplify this, sin x into e power x integral is e power x minus d by dx of sin x is cos x. E power integral is e power x into dx. I have applied integration by parts. One more integral is there. There also we have product, no? Again I should apply integration by parts. Trigonometric function, it is first function u. Exponential, e comes last in the phrase isolate. Therefore that is second function. So if I apply again integration by parts, u into integral v dx minus integral of d by dx of cos x into integral e power x dx. For entire product, once again integral. Yes, now what this becomes? This is e power x into sin x minus of, what is there? Cos x into e power x derivative e power x only, minus into minus plus. What we will have? D by dx of cos x and integral e power x integral e power x only. Cos x derivative is minus sin x into dx. This minus can be written here, plus into minus minus. You please see, what was our problem? Our problem was integral of the product e power x into sin x. So we have applied, there are two functions, we have applied integration by parts. Still same product has come. Are you following? By we have to actually integrating this. Since there are two functions, we need to apply integration by parts. We have applied. Of course, we have applied two times. Still the same function is there. If you integrate it, if you integrate again, you will be getting same function. This integration part, that portion will not be ending. For such functions whose integration is not ending, we will use reduction. We reduct this. In the integration by parts, last video we have seen two particular formulae. Integral e power ax into sine of bx plus c. That was also same. When integration is not coming to an end, then we will reduce that integral. This process is called successive reduction. Integration by successive reduction. In this part we will find the formulae. That means we will find the integrals of some particular standard integrals. Let us see. Firstly, we will see one standard one. Number 1, integral sine power nx dx. So we have integral for sine x in the beginning, but when square is there, cube is there, we did not find the formula. Now we are doing that. Integral sine power nx dx. I have to find its integral now. I will write this as sine power n minus 1x into sine x. So there are total n sines. I written as n minus 1 and 1. Total again n only. So again here we obtained product. When product is there, integration by parts should be applied. When you want to apply integration by parts, you need to select the functions. First function, second function. Generally that will be done using the phrase isolate. But here both are trigonometric functions. So while selecting the first function, second function, in the last video I said the second function should be very simple to integrate any number of times. By comparing these two, this will have integral directly. So I will take that as second function and second function. This is second function means v. The remaining will be first function. Let us see carefully. See the simplification is how we are doing this. I am using integration by parts. Sine power n minus 1x into integral sine x dx, which is second function, minus integral of d by dx of first function. What is first function? Sine power n minus 1x into integral v dx. Integral sine x dx. For entire this again we have one more integral. So I have applied integration by parts. Now see carefully. What is integral of sine? What is there here? Sine power n minus 1x. What is integral of sine x? It is minus cos x. So I will write minus here. Then what will have? Integral of derivative of this. This is differentiated using x power n because power is there. N minus 1 into, that is n into x power n minus 1. Already n minus 1 is there, no? N minus 1 minus 1, n minus 2x. I have differentiated this. I applied x power n. In place of x, what is there? Sine is there. Again I have to differentiate that into cos x we get. And integral sine x is what? Minus cos x. Minus into minus plus. One more cos, no? This becomes cos square x into dx. Therefore, this is equal to minus of sine power n minus 1x into cos x plus I will write n minus 1 outside. Then what we have here? Sine power n minus 2x. Here cos x whole square means cos square x. I will write this as 1 minus sine square x into dx. Okay. So I will suppose the given integral is I. Okay. Therefore this is minus sine power n minus 1x into cos x. Carefully, n minus 1 into integral of this. N minus 1 is for entire this thing. Here I will multiply sine power n minus 2 into 1, which is sine power n minus 2x into dx. Then plus into minus minus. For this also n minus 1 will be there, also integral. Sine power n minus 2 into sine power 2. Adding powers, this becomes sine power n. So again question has repeated. This is not ending. Therefore we should reduct that. So therefore I will write this as minus of sine power n minus 1x into cos x. Carefully, this is n minus 1 into, what is there, sine power n minus 2. When sine power n is there, we will denote this by in. Okay, no problem, in. Here is same function is there. What is the power? N minus 2. Therefore I can denote this by in minus 2. Next, what is there? Minus of n minus 1 into sine power n is in. In this result, we have to find this integral which is denoted by in. That means we have to find in. So in is here also, which is negative. Write it on left side and you take in common. If I take in common, here I will have 1. The term become plus, no? If I take in common, I will be having n minus 1. What will be there on the right side? Minus sine power n minus 1x into cos x plus n minus 1 into in minus 2. This we have written on the left side. Here minus 1 plus 1 gets cancelled. Therefore from this, what is in? In is equal to, this n is there here. If you write on right side, it divides. Therefore minus of sine power n minus 1x into cos x plus n minus 1 into in minus 2. So this n divides, no, it divides both of the terms on right side. So therefore this is given integral sine power n, which we have denoted by in. Therefore this in is equal to this. This is known as a reduction formula for sine power nx. What is this? This is known as a reduction formula for sin x, sine power nx, of course. Yes, this formula is applicable for n greater than or equal to 2. If n equal to 0, if you write 0, something power 0 is 1, 1 integral is x. If you take n equal to 1, then what is this? This is sine power 1, means sine has standard integral minus cos x. So this should be applied for n value equal to 2 or greater than 2. This is known as reduction formula for sine power n. Yes, we will see how to apply this formula. See Nana. Just now we have seen integral sine power nx dx, whose power is n, denoted by in. Its integral is minus sine of n, sine power n minus 1x cos x by n, plus n minus 1 by n into in minus 2. This is the reduction formula for sine power n, applicable when n is greater than or equal to this. We will see an example how to solve a problem. For example, integral sine power 5x dx is given. Listen carefully. What is there here? In place of n we have 5. Therefore, what is this symbolically? It is I5. Yes, I will use the reduction formula. In this problem, n value is 5. What will be the integral? Minus sine power n minus 1 means 4 into cos x divided by n. What is n? N is 5. Plus n minus 1. What is n minus 1? N is 5, no? 4 by n is 5 into I n minus 2. In the problem now n is 5. 5 minus 2 is 3. So again integral is there. So therefore this is equal to minus sine power 4x into cos x divided by 5. Here 4 by 5 is coefficient into. Now we will write I3. In this is the reduction formula. Now for this, what is n value? 3. Therefore its integral will be minus sine of. What is n? N is 3. n minus 1 is 2 into cos x divided by n. What is n now? 3 plus n minus 1 concentration by n into I n minus 2. 3 minus 2 is 1. So therefore now this is equal to minus sine power 4x into cos x whole divided by 5. Here I will multiply plus into minus minus 4 divided by 5 into 3 15 into we have sine square x into cos x. This 4 by 5 multiplies this also. Therefore we will get 8 by 15. And what is there? I1. For 1 you should not use this because it is for only n greater than or equal to 2. I1 means n equal to 1. Very simple. If you take I1, that means if you take n equal to 1, what the given integral becomes? Sine power 1. Sine power 1 means only sine. What is integral sine x? Minus cos x. Therefore plus into minus minus cos x plus c. Therefore this is the answer. So in this way we solve these reduction problems. So I have done sine power n. No. Similarly there is another one, number 2. What that number 2? See now. If in is equal to integral reduction for cos power nx dx, then I have done sine power n proof. No. Similarly you do this, take it as homework. For this in reduction will be cos power n minus 1x into sine x. Same procedure divided by n plus n minus 1 divided by n into in minus 2. This is also applicable for n greater than or equal to 2. Therefore this is the second one, reduction for cos. Proofs of these reduction formulae, they are very important. They will be asked in the final exams in long answer type questions. Therefore you must practice them. So I have done sine power n. No. What I did? Sine power n. I wrote it as sine power n minus 1 into sine. No. You proceed in the same way. Cos power n is cos power n minus 1 into cos. Take integration by parts and you will get this. Please note. Next we will see the reduction formula of tan power nx. See number 3. Integral tan power nx dx. So I will try to find its integral and I will write this as tan power n minus 2x into tan square x. Yes. Now I will simplify this as integral tan power n minus 2x. So there are two functions. Its integral at the moment directly cannot find. Tan square also there is no interval. If tan is there, there is a integral log of sec x. In the previous sine power n minus 1 into, there we write sine x, which is a standard integrand. So here this is not a standard integrand, therefore I will write this as tan square x is secant square x minus 1 into dx. Carefully. What is this? Now this is integral of, I will multiply here tan power n minus 2x into secant square x dx. Then plus into minus minus. For this also, this into this. What is this now? Tan power n minus 2x into dx. If you proceed like this, this will be, this is n minus 2, no? Next n minus 4 will come, n minus 6. Integration never ends. Therefore, we should reduct this. Here see the integral of this. Here tan x is there, here secant square x. What is secant square x? It is a derivative of tan x. Therefore, I will suppose this is f of x. What is this? F dash x. We have a formula. Integral f of x whole power n into f dash x dx. What this formula says? If it is f of x whole power n plus 1 by n plus 1. See the list. So I am going to use that. This is fx whole power n into f dash x. What is that integral? Fx whole power n plus 1. That means n minus 2 plus 1. Nothing but n minus 1. Divided by also n minus 1. Next minus. What is this? I will denote this given integral by in. If I denote this by in, what will be that one? That is power n minus 2, no? And that can be written as n minus 2. That's all. Therefore, if I denote integral of tan power nx dx by in, then this integral will have the reduction. Then this in is equal to tan power n minus 1x divided by n minus 1 minus in minus 2. This is the reduction. Again, it is true for n greater than or equal to 2. So this is the reduction formula for tan power n. This is also important in descriptive exams. This proof is important. Therefore, what is this? Tan power nx into reduction formula. Similarly, in the same way, you can take fourth one. Reduction for cot. If in is equal to integral cot power nx dx, then what will be its reduction? For this, in is equal to minus of cot power n minus 1x divided by n minus 1 minus in minus 2. This is also applicable for n greater than or equal to 2. Yes, this is the reduction for cot. So take it as another formula. Reduction for cot. Yes, this is reduction for tan power n and this is reduction formula for cot power n. Yeah, we have seen tan power nx reduction, cot power nx reduction. How to apply that? We shall take an example. Evaluate integral tan power 5x dx. What is there? Tan power n. Here we have 5. Therefore, n equal to 5. That means it is I5. Now this is to be found using this reduction formula. What the formula says? Tan power n minus 1 divided by n minus 1. N is 5, no? N minus 1 is 4. Minus I n minus 2. 5 minus 2 is 3. Again here you should apply this reduction. What is this? Tan power 4x divided by 4 minus of. Minus is there, I shall take bracket. What is I3? N equal to 3. Put n equal to 3 in this. Then n minus 1 is 2. Divided by n minus 1 is 2. Minus of I n minus 2. Now n is 3, no? 3 minus 2 is 1. Yes, therefore this is tan power 4x divided by 4 plus into minus minus tan square x divided by 2 minus into minus plus I1. This is applicable for n equal to 2 or greater than 2. For 1 you cannot apply this. 1 means n equal to 1. Put n equal to 1 in this. Then this is a simple integrand. Integral tan x. What is integral tan x? Log of sec x. That's all. This is the problem. Yes. Now let us see into reduction of sec power n. I shall denote this by in. Let us start this. I will write this as sec power n minus 2x into secant square x dx. So this is not having integral directly, but secant square has integral directly. Therefore this is second function and this is first function. Directly you can apply integration by parts. First u into sec power n minus 2x into, I am writing directly, integral v dx. Secant square integral is tan x minus integral of, carefully, d by dx of this. I will apply x power n, which is n into x power n minus 1. That means n minus 3. I have applied x power n. In place of x, sec is there, no? Again I have to differentiate that. Differentiating sec, we get sec x into tan x. And what is integral of this? It is tan x. Therefore tan square x. I wrote direct step, no problem. Now what is this? It is sec power n minus 2x into tan x minus of n minus 2. Constant I wrote outside. Sec power n minus 3 into sec power 1. This becomes sec power n minus 2x. And what is there? Tan square. If you want to apply integration by parts, for tan square there is no direct integral. Therefore I will write tan square as secant square x minus 1 into dx. Yes, therefore this is equal to sec power n minus 2x into tan x minus of n minus 2 into integral. Let us multiply. If I multiply these two, I will get this sec power n minus 2 into sec power 2. This minus into minus plus. N minus 2 will be there for this also. Integral of sec power n minus 2 into 1 is sec power n minus 2x dx. So therefore what is there on the left side? Left side we have in, which is equal to sec power n minus 2x into tan x minus of n minus 2 into. This is nothing but in plus what is there? N minus 2 into this can be in minus 2. Here we are finding this. That means we are finding in. So there is one more in here, no? Writing this on left side, you take in common. By taking this in common, 1. This term becomes plus, no? If you take in common, you will have this. So what will be there on the right side? Sec power n minus 2 into tan x, and also n minus 2 into in minus 2. So what is this now? Minus 2 plus 1 is minus 1. That means n minus 1. Write n minus 1 on other side. So sec power n minus 2x into tan x. This n minus 1 divides, therefore n minus 1. N minus 1 divides this also into in minus 2. So this is the reduction for sec power n. Proof is also important, this one. This is also applicable for n greater than or equal to 2. We have seen sec power n reduction. Now we will apply this by taking an example. Integral sec power 4x dx. Yes, sec power n. Here sec power 4. That means n is equal to 4, which is I4. This is the reduction of sec, no? N equal to 4. Substitute here. This is sec power 4 minus 2 is 2 divided by n minus 1. 4 minus 1 is 3. Then plus n minus 2. N is 4, no? 4 minus 2, 2. N minus 1 is 3. And I2. What is I2? If you write 4 here, this is 2. So therefore this is equal to sec square x divided by 3 plus 2 by 3 into I2. If you take 2 here, this will be secant square x. Secant square x is directly, it has integral. Integral secant square x is what? Tan x. That's all. Plus c. So in this way we solve the problems. So there is a reduction formula for cosec also. Therefore if in is equal to integral cosec power nx dx, then in is equal to minus cosec power n minus 2x divided by n minus 1 plus n minus 2 by n minus 1 n minus 2. This is the reduction formula for cosec. Procedure, derivation procedure is same as sec power n. This is applicable for n greater than 2. This is also applicable for n greater than 2. If n equal to 2, this becomes direct sine square. Sec square. Sec square is a standard integrand. Yeah. We have completed reduction formulas of sine power n, cos power n, tan power n, cot power n, sec power n and cosec power n. So I have derived 3 and I asked you to derive the remaining. Okay. There is one more which is also very useful in objective. What is this? This is reduction of this sine power mx and cos power nx. Sine and cos. If integral this one, sine power m cos power n, we will denote this integral by imn, that means with these powers. Imn means sine power is m and cos power is n. If an integral is of this type, then what is its reduction? Its reduction can be done in two ways. In first reduction, cos power n can be written as cos power n minus 1 into cos x. You will get one result. If you split sine, you will get another result. So these two also important. Please learn these. Yes. For the reduction of sine power m cos power n, you can take either first one or second one. Yes, these are the reductions. In both m and n are natural numbers, both greater than or equal to 2. Yes. Still, for many functions whose integrals are not ending, for them also you can use reduction. Yes. So this is my 9th video on concepts of integration. So we have almost completed this integration total concepts. So you please go through the videos in order. I made all the 9 videos in order, concepts in order. Yes. Next, in upcoming videos, we will see the objective problems of mains and advance. Okay, thank you.